Oh, right, you can't even see my screen. Okay, so our critical value is positive negative 0.754. My R is negative 0.944, so it's way over here. What are we going to do with H naught? Reject or not reject?
Reject.
So reject H naught.
It's a line.
It's a line. Is a line. Great. So it means I can use this. I can use my formula. So my formula is y equals, what did you guys get? You plugged it in? 102.5 plus minus
Negative 3.62.
3.62x. Everybody on board?
Yep.
Can I use that or not use it? Should I use it or not use it?
You use it.
Use it, because I do have a line. You guys follow?
Yes.
All right, so I want to know for 17 absences. So y equals 102.5 minus 3.62 times 17. And what did you guys get for that? 40.9. So in other words, this person's totally going to fail. Which, I mean, if you're missing over half the classes, then you probably aren't going to fail. Good? You probably are going to fail. Sorry, I'm sort of sick.
Good words.
All right. Good. Now we're going to shift it. What if our R had been 0.323? Then what would happen? So draw yourself a new picture.
Where?
Down below.
Down below.
I write pretty small there.
All right, just roll with it. Or you can put it in the top one up here too. That's even fine. If R was 0.323, then what?
Then we would do the average.
Then is it a line or not a line, guys?
Not a line.
So not a line,
It's still outside of the changes. So
right? Do not reject H naught. Not a line. So then, to figure out what the grade would be, you'd use what?
At the average of y.
So everybody do that. Take 15 seconds with your neighbors and do it. Find it. So you got to predict somebody's grade in that case.
do one bar stats minus those two. Yeah, one bar stat. We'll delete this first. You go stat.
Y bar is it's not, oh my god. This one's the Y bar, so Y bar.
This one minus.
No, it's just going to be list two. Because you just want the average of it. Right?
The R changed. Instead of it being this.
But doesn't she already have?
I know.
So when you create what do you do after you find the average?
That would be what vectors. I don't know. I don't know.
Oh, I need to take a break.
Wow, we're getting a lot of paperwork today. How many trees?
Sorry, bro. We were discussing
Oh, I call Why do we have two of these?
All right, so what you use then to predict the final grade?
Average.
Average of y's. So your y will equal the average y, which is what? How do you find that?
Add them up and
Add them
divide
all
it.
up and divide by.
You don't even have to do that. You already have it.
One bar stats.
Yeah, one bar stats. So what do you guys do when you get one bar stats?
73.
73?
Yeah.
Good? Everybody on board?
Yes.
Just use one bar stats and find your y bar. The average of whatever list you have your y's in.
It's just for your Y-bar.
Right, now if you do one bar stats, it's going to call it x bar, because it calls them all x bar. You guys understand what I'm saying? You know you put y's in there, so it's all good. Alright, so we're going to skip the last, we're going to do that lab problem 6 next class. We're going to jump into our chapter 11 notes. So, chapter 11 notes. Chapter 11, we're going to cover 3 tests in chapter 11. The first one is this one, the goodness of fit test.
Way too many papers today.
How many participants did you guys end up getting in here?
All right, Michael, go ahead and read for us.
The chi-square can be used to see whether a frequency
Did you read the first part? Read the title.
is a specific pattern.
Emily.
Test for goodness of fit. The chi-square.
Oh, sorry. So this is called chi-squared, like kite. Everyone say kite. Kite. It's chi-squared. It's not chi. It's chi. Everybody good? Okay, keep going. Keep going.
Oh, the chi-square statistic can be used to see whether a frequency distribution fits a specific pattern. This is referred to as the chi-square goodness of fit test, which tests the claim that an observed frequency distribution fits some expected frequency distribution.
Right. So our H naught is going to be that our observeds equal our expected. So our O sub I equals our E sub I. That means that our I means like you count them from like 1 to whatever. So like our first observed equals our first expected. Our second observed equals our second expected. Our third observed equals our third expected, and so on. That's what that little sub I means. It means that through all the different ones we have. H1 is that O sub I does not equal E sub I. In other words, what actually occurs is not what you expected. Good? Pretty much for these ones, H naught is going to be our claim. Our claim is going to be H naught pretty much always for these. So we're always going to look to either reject or fail to reject our claim. They're almost always going to be H naught. Okay. So everyone on board with this step 1? That's our step 1. Here's some assumptions. Simple random sample. And our expected frequency has to be 5 or more. So the first thing we did is, all we did in chapter 10, those were all means, right? We could find an X bar, we could find a Y bar, right? Our data was numbers. Here with these guys, our data is going to be yeses and nos. So these are going to be counts. They're going to be frequencies. So it's kind of like, eye color. I had blue, I have green, I have hazel, I have light brown, I have dark brown. Right? You're gonna have categories, and you have a certain number in each category. So this is gonna be your categorical data. Here's some notation. Dana, go ahead and read.
Observed and expected frequencies. O represents the observed frequency of an outcome found by tabulating the sample data. E represents the expected frequency of an outcome found by assuming that the distribution is as claimed. K represents the number of different categories or outcomes. And N represents the total number of trials or observed sample values.
Right, so K is our number of categories. So if we have 5 different eye colors, then our number of categories would be 5. And then N represents the total number of people you asked. Right. So here's our formula. This is called chi-squared. It's not x squared. It's a swishy thing with a line across. That's a chi. Everybody on board? It's not an x. Do not confuse it with x. This is chi squared. That's its whole phrase. We do not find chi and then square it. The name of it is called chi squared. Do not ask me why. Maybe Martin can tell us about it later, not now.
Okay.
But that is its symbol, chi squared. Good? Do not take x and square it. You're going to be in so much trouble on this exam because this is worth a fair amount of points, right? Sections 11.1 and 11.2. So yeah. So chi squared. It's the sum of, you take every single O, observed value, subtract the expected value, so see how far it is from the expected value, square it, and divide by the expected value. You do that for each individual category, and then you sum them, you add them up. That's your chi squared. Degrees of freedom is the number of categories minus 1. Okay, so, all right, so far? Okay. So we're just going to walk through one of these examples. This is the very first one. It's midway, it's at the bottom of your page. So some guy says, well, I think that people prefer all 5 flavors of this new fruit soda the same. He asks 100 people. If you ask 100 people and there is no preference, then that means how much should be in each category if there's no preference? 20. Right? They should all be what? Different or the same? Same. If there's no preference, they should all be the same. Everybody understand? I have 5 categories. I have 100 of them. That means I should have 100 divided by 5 categories, 20 in each. Good? So my expected should be 100 divided by 5. In other words, it should be my n divided by k. Everybody good with that part? So it's going to be 20 in each. You should be writing this down as we do it.
We don't even have the data.
Oh, you know the data, sorry. So you're good. My hypotheses should be H naught is O sub I equals E sub I. Write that down then. And my H1 is O sub I is not equal to E sub I. That's O sub I equals E. When I say sub I, it means the subscript I.
H naught's the claim, right?
H naught's, yeah. H naught is almost always the claim on these. So if you use H naught as a claim, you'll be fine. You'll be fine on the final. Okay. Now, step 2, we need to figure out our degrees of freedom. So here, chi squared is, do you guys see it? It's like a little, it goes like this. It goes up, and then kind of slips off, like that. It shoots straight up and slips off. It is right-tailed only, because it starts at 0, and then goes up from there. Starts at 0, and then goes on to infinity. So it's only right-tailed. And how many categories do I have? 5. So my degrees of freedom is going to be what, guys? 4. Degrees of freedom is 4. Did I say alpha is, oh, here's the thing. So if you look at this table here, you will see there's a whole bunch of stuff. We are only going to use these 3 columns. We're really only going to use the alpha is 0.10, 0.10, 0.05, and 1%. 1%, 5%, and 10%. We're only going to use those ones. If you want to circle those, with a colored pen or a marker or whatever, so you kind of realize that those are the 3 you should dial into, that's probably a good idea. For us, our degrees of freedom is 4, so it's going to be our alpha is 0.05, so I get 9.488. Yeah? Everybody on board with that part? Give me thumbs. I got it, not so much. Okay, so check with your neighbors. So this little subscript tells you the alpha. Square
Tell
root
the
of
table
5.
to have on the test.
Yeah.
This column over here gives you degrees of freedom.
Ooh, yeah.
Wow.
Okay. So my critical value is going to be 9.488. I'm going to put it in right here and shade. 9.488. Now I need to figure out my test value. So it's pretty straightforward. It's going to be my chi-squared is equal to the sum of these guys. The sum of my O sub I minus E sub I squared over E. So it means I need to take every single O, subtract its E. So here I have 32, subtract 20, square it, divide by what I expect, 20. Next one, 28 minus 20 squared over 20.
Oh boy.
Yep, hang on. So I'm just going to do these really quickly. 16 minus 20 squared over 20 plus 14 minus 20 squared over 20 plus 10 minus 20 squared over 20. All right,
I like
so
that.
here's the thing, and then I'm doing this part, and then I'm going to add them all up, right? That's the summing part. You can just put them in a list. You can do it, but here's the thing. On the exam, you're only going to have like 3 categories. So it's really as easy to do this if you wanted to than it is to do the calculator steps. But if you look at your notes, we can do the calculator steps. So what is that? You put the O values in L1, E values in L2, and then compute in L3. So let's go and try that. Stat, edit. I have to go up to list 1 and hit clear enter to clear that out. Go up to on L1 and hit clear and enter. I'm going to put these in. What do I got? 32. It's 32, 28, 16, 14, and 10. What's up with 10? Grape only has 10. I love grape soda. Should be way much bogus. All right. Now then my expected values are 20 for each of them. All right. So 32, 28, 16, 14, and 10. You guys can see that, all right?
They compute in L3.
And then in L3, okay, so I'll go back over here, make sure everyone has these numbers. Can you guys see them okay up here?
Uh-huh.
Okay. And then don't forget, I want to do my O minus my E squared divided by my E's. I need to find all of those. Everybody know what I'm saying? I need to find this part right here. So I'm going to do, I need O minus E squared over E. I need that. Right? I need that in list 3. So that's going to be, how do I do O minus E squared?
Comma L1.
Yeah. So what's my O's? Where are my O's?
L1.
L1. Where are my E's? So minus L2 squared. So this is how you do squared in the calculator, right? And then since it's just E's by itself, I can do divided by L2. So that's what we're going to do. Did everybody write that down? You might want to write it down.
Oh boy.
I'll give you guys just a second to write it down. Okay. All right, so let's go ahead and do it. So L3 is parentheses L1, second L1, minus second L2, end parentheses, squared, raised to the second power, divided by L2, second L2. So it should be right in there, just like that. And remember, you have to be in L3 to do that. You can't be sitting here on the line. You got to be up. Your black thing has to be on the L3 itself, or else you're going to get an error. And then, so they enter, boom, all of them come in.
Booyah.
Good? Now I'm not done. I need to sum these. How do I add them up?
Wait out.
1 minus.
Stat, calc, 1 bar stats of L3. And boom, it gives me my sum of my x's. You guys see it right there?
Yeah.
Sum of x's is 18. Everybody on board? Okay. Who has a fancy CI-84? I think you guys can do it faster with a goodness of fit test, GOF test. So you might be able to do this. Stat test, go up. GOF test, goodness of fit test. L1, L2, degrees of freedom.
Well, that's easy.
4. Calculate. And it should give you there. So you should all find it faster and easier. So that's one of the rare times when the 84. That's why the 84 is a little bit better than the 83. But it's only for this one type of problem. It's nothing else really helps you that much more. Okay. So here, then for this one, if I did it this way, I would do the chi-squared is equal to the sum of list 3, which is 18. Everybody on board?
Is this part of step 3 still?
Yeah, it's step 3.
Okay.
So this is all step 3. You can either do it manually the blue way, and you'll get 18, or you can do it the calculator way and you can get 18. Either one of those will work. It's just option A for step 3, option B for step 3.
Write all that.
Yeah.
Okay. Super duper.
Okay? Now, I do want you to do this though. You have to write, I want you writing this stuff. So, I do want you to write, and like I said, it's only going to be like 5 items, 3 items, it's not going to be this many. I want you to write this part for me. And then you can calculate any way you want. You guys understand what I'm saying? This is just showing your work. Show work. Because like I said, I'm only going to give you like 3. So you can write down 3. It's not that hard. The first semester I taught this, they had to do 9, and they had to write it all out by hand, and they couldn't use lists at all.
What is this?
This is 5 years ago.
What's wrong?
Damn.
They did great. They were awesome.
You suck, I guess.
Made some mathematician.
Yeah. Not a mathematician.
All right. So that's step 3. Now you need to put it in there. Where does it go? Where's 18 go here, guys?
TS.
Yeah, way out here. You guys follow me?
Yeah.
18 is beyond the 9.6.
Beyond me.
So this is my 18. That's my chi-squared. And am I going to reject H naught or not reject H naught? Reject. Everybody on board with that?
Yeah.
So step 4. Reject H naught. And then step 5. Enough evidence to, again, H naught's my claims. These are always going to be to reject claim of, in this case, what was the claim that there's no preference?
Equal flavor preferences.
Of no preference. Or equal preference among flavors. As Martin said, you can say equal, that's fine too. Soda flavors. I think it was wrong. I mean, I like cherry too. Cherry's pretty good, but I think I still would take grape over cherry. Oh yeah, cherry.
Yeah, I'm an orange guy. I like Crush and Fanta.
I hear you.
Orange juice smack.
Grape.
Grape's great. Like some grape is good.
Well, would.
See, I feel like all like strawberry soda tastes like medicine kind of.
Yeah, all of that tastes like chemicals.
Like Boss?
Like I'll take Fanta. Fanta's always good. I love Fanta.
Are we done?
Okay. Is that a wrap?
That's over.
So guys, here it is. If you want it written out, here it is, kind of prettier, right? Kind of give you a little more clear way of showing it.
These are quite great. Quite great.
Of course.
All right. So let's just take a second, and I want to talk a little bit about your project.
Oh yeah, you gotta get
You have to.
Are you gonna get us a cup?
Oh yeah. All right, give me 1 minute to talk about your project. 2 minutes. So this is the final part of your project. Correlation regression. It has to be done in Excel. I think there's one other thing that matches up with Excel, but Sheets won't do it. You can't do it in Sheets because it just won't work. So you're going to use Excel to create a scatter plot of two quantitative data sets. So you picked two numerical data sets, right? Use the two numerical ones you picked. So you're going to test and see if there's a correlation between them, and see if, based upon your conclusion, use an appropriate method to predict a value within the range of your data. So it means that if you have a correlation, if you reject H naught, you'd use your AB line, your Y plus A plus BX. If there's no correlation, you do not reject H naught, then you'd use the average Y or the average X. You'd use the average Y, yeah.
So it'd be like height and then hours spent studying?
Yes.
Okay.
Exactly. So write down the two you picked originally. Remember, I have those written down, so you should stick with the ones you wrote down, or else you're going to lose points on that. And then, which data set would treat as your X? So pick one of them to be the one you think, forces the other one to be a certain way. So maybe your age might determine how much sleep you get, right? And so then write down what that is. And then pick a value for X that you want to make a prediction of. So maybe you might say, okay, if it's age and, you guys play, age and how much sleep you get, you might say, well, I want to know how much a 40-year-old would sleep a night. So you pick, X is 40. And circle this so that you can find it later, because you're going to need to use it later. So I want to say, well, I want to know when X is 40, or when age is 40, what it would be, and circle it. Circle it on the page, because you're going to grab it later on, and you want to be able to find it fast. What's your initial impression? Do you think there's a linear correlation or not? Just give me 7 things. I think it's correlated because blah, 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 or I think it isn't. Older people sleep less, or more, I don't know, whatever. They usually sleep less. Yeah. Go to our class survey link, copy both of them, right? Control-C to copy it, and then open a new Excel sheet and use Control-V to paste them in there. It's really important that if you're missing something, you delete that and you don't use that whole one. So you just remove that out. So take out the age. You guys see what I'm saying? Mm-hmm. So if you have this 34, nothing there, then you just take out the 34. So it's cleaned up like that. And then it talks through about using the Correl function, highlighting it, and then label it by typing R equals with parentheses around it in the cell before it, so you can kind of see that's label R equals, and then tell me what R equals, because the Correl function will give you that equals Correl parentheses, and then grab this stuff, and then do slope, and then use intercept, and then use average for each of both columns. And then make a scatter plot. So it kind of walks you through how to select them, and then do a scatter plot, and then add a regression line to the scatter plot. It kind of walks you through how to do that. You right-click at any of the points, and it'll bring this up. And you hit linear, and it kind of shows you how to do that. Print out 2 copies of that active worksheet, including your calculations and the scatter plot. One has to be with the numbers in it, and one with the formulas in it. So you go to show formulas in there, and it will show me the formulas, and I need both of those. I need to see the formulas. And then do a correlation test. neatly on a separate piece of paper. And then you're gonna predict, like I said, if it is a line, you're gonna grab that x value you picked on the first page, and if it's, you're gonna tell me what your y equals a plus bx gives you, and then you're gonna predict it. If it's a line, if you reject h naught, then you use that line. If it's not a line, if you did not reject h naught, then you use the average y. Good? Alright.
And these are the questions from our original.
Yeah, when you originally picked. If you have an issue with it,